Hello everyone. In this video, we are going to discuss the second topic under trigonometry, and that is on circular functions. So here we will be applying all the things that we have learned in our previous lesson. Specifically, we are going to first illustrate the different circular functions. Then after that, we will use reference angles to find the exact values of these circular functions. Okay, so let's get started. So what are circular functions? So circular functions are actually special type of functions wherein the domain of our functions here are sets of angles in standard position. Also, circular functions are used to describe phenomena that happen periodically, meaning those are events that repeatedly happen over a certain time interval. To know more about these circular functions, let's consider this definition. Let theta be an angle in standard position and P of theta be the point xy on the terminal side of angle theta on the unit circle. Then we have the following circular functions. First, we have sine theta. Sine theta is equal to y. Therefore, sine is just the value of the y-coordinate of the point on the terminal side of our angle theta on the unit circle. Okay? While cosine theta is equal to x. So that is the value of the x coordinate or the abscissa of the point. Okay? Then we have tangent theta, which is equal to y over x. Here, x should not be equal to 0 so that the value of tangent theta will be defined. Okay? We also have here cosecant theta, which is equal to 1 over y, where y is not 0, so that the value of cosecant will be defined. So as you can see here, cosecant theta is actually the reciprocal of sine theta. Okay? We also have here secant theta. Secant theta is equal to 1 over x, where x is not 0. So here, secant theta is the reciprocal of cosine theta. And lastly, we have cotangent theta, which is equal to x over y, where y is not 0. So cotangent is the reciprocal of tangent theta. Now let's discuss how we obtain these formulas here. Okay, now suppose we have this unit circle. And suppose we have this angle theta in standard position. Okay, now for us to have these six circular functions, we need to know the coordinates of the point here on the terminal side of our angle theta, this one. Okay, and it has the coordinates xy. Now, if I'm going to project that point to the x-axis, I can actually have this right triangle. Okay, and take note, whenever we have a right triangle, we can apply trigonometric ratio. If you can still remember the trigonometric ratio in your previous math lessons, so trigonometric ratio is actually yung SOHCAHTOA TOA na alam nyo. So means sine theta is equal to opposite over hypotenuse. Ka means cosine theta is equal to adjacent over hypotenuse, while TOA means opposite, tangent theta is equal to opposite over adjacent. Now, let's try to derive the formula here of the six circular functions using this right triangle. Now, take note, our point here has the coordinates xy. And since this is the center of this unit circle is at the origin, so that is 0, 0, then going to here, this is just y. Therefore, the length of this side here, okay, so the length of this side here is equal to y. And the length of the side here is equal to x. And this is now our hypotenuse, right? Now, using the trigonometric ratio, let us first identify sine theta. So sine theta is equal to the side opposite of angle theta over the hypotenuse. So here we have sine theta is equal to opposite over hypotenuse. So the side opposite of angle theta is just y, right? So we have y over the hypotenuse, which is equal to h. Now, take note, this length here is just the radius of our circle. And since this is a unit circle, so the radius here is equal to 1. So it follows that the hypotenuse is just equal to 1. Therefore, we have y over 1, or just simply y. That's why we have sine theta equal to y. Okay? Now, how about for cosine? Ka. Ka means cosine is equal to adjacent over hypotenuse. So, therefore, we have cosine theta is equal to the side adjacent to angle theta, meaning yung side na katabi ni angle theta other than the hypotenuse. So that is your x, right? Over hypotenuse, so we have x over 1, which is equal to x. That's why we have cosine theta is equal to x. Okay. Next, for the last one, TOA means tangent equals to opposite over adjacent. So we have tangent theta is equal to the side opposite, that is your y, and the side adjacent to angle theta, that is your x. So we have y over x. That's why we have tangent theta is equal to y over x. So given that x is not 0. While the remaining three circular functions, we will just take the reciprocals nung tatlong naunang function. So cosecant, reciprocal ni sine. Second, reciprocal ng cosine, at cotangent, reciprocal ng tangent. Okay, so I hope this is clear now. Now, let's try to apply these formulas here to find the value of the circular functions of a given angle. Okay, so suppose we are to find for the values of the six circular functions of angle 135 degrees and negative 60 degrees. Let us first have the angle 135 degrees. Suppose this is our unit circle. Now, since this angle 135 degrees should be an angle in standard position, therefore, our initial side is located here on the positive x-axis and the vertex is at the origin. And we have here the terminal side. So this angle measures positive 135 degrees. Now we need to know the coordinates of this point here on the terminal side of angle 135 degrees. Okay. Now suppose I'm going to project this point to the negative x-axis, so I can actually form a right triangle here. Now, take note, the measure of a straight angle is 180 degrees. And since this one here measures 135 degrees, it follows that this angle here sa baba is equal to 45 degrees, right? So, now let's take this right triangle here. Okay. Now, we already know that the a measure of this angle here sa baba is 45 degrees. This one is 90 degrees. Recall that the sum of the interior angles of a given triangle is 180 degrees. Therefore, it follows that the measure of this angle here on top is equal to 45 degrees. So from that, we actually have a special right triangle, 45, 45, 90 triangle. Okay, so that is a special type of right triangle, or as an isosceles right triangle. Okay, so if you can still recall, whenever you have a special right triangle, we can actually have the length of the sides of this triangle given the length of the hypotenuse. Now, take note, going back to our illustration here in our unit circle, the terminal side of this angle here corresponds to the hypotenuse of our right triangle. And since this angle is an angle in a unit circle, so the measure of this terminal side here is just equal to the radius of the unit circle, and that is equal to 1. So we have r equal to 1 here. So it follows that our hypotenuse here is equal to 1 unit also. Okay? And recall also that in a 45, 45, 90 triangle, the legs are equal. Therefore, this leg here is equal to this leg here. Okay? And the legs are square root of 2 times half of the hypotenuse. So given the length of the hypotenuse, we can actually have the length of the legs of this triangle here. And since the hypotenuse has a length equal to 1, so half of that is 1 half. Then multiply it by square root of 2, that will be the measure or the length of the sides of our right triangle here. So half of 1 is 1 half. Multiply it by square root of 2. Therefore, the length of the side here is equal to square root of 2 over 2 as well as the length of the side here. Okay, so we have now the lengths of the sides of this right triangle. So it follows that the length here going back to our unit circle from the origin to the side or this side here, horizontal side of this right triangle is equal to square root of 2 over 2. And for the vertical side, that is square root of 2 over 2 also. Okay? So from that, we can now identify the coordinates of the points here that corresponds to the angle 135 degrees. Okay? And since this point here is located at quadrant 2, so it follows that our x is negative and y is positive. Therefore, it follows that P of 135 degrees, or the point on the angle 135 degrees, is equal to negative square root of 2 over 2 and square root of 2 over 2. So our x is negative square root of 2 over 2 and our y is positive square root of 2 over 2. So from that, we can now solve for the values of the six circular functions of this angle 135 degrees. Okay, so let's start with sine 135 degrees. So sine 135 degrees is just equal to the value of the y-coordinate of the point on the terminal side of angle 135 degrees. And what is the value of our y? That is just equal to square root of 2 over 2 positive. So that is now the value of sine 135 degrees. Okay, next for cosine. So cosine 135 degrees is just equal to the x coordinate of the point. And that is equal to negative square root of 2 over 2. Okay, so that is the x coordinate of the point. Okay, so we are done with sine and cosine. Now let's move to tangent. So tangent 135 degrees, that is just equal to y over x. Okay, so we will just divide y and x. So y is square root of 2 over 2, while x is negative square root of 2 over 2. So square root of 2 over 2 divided by negative square root of 2 over 2, this is just equal to negative 1. So we are done with tangent 135 degrees. Now let's move to cotangent. Okay, so cotangent is just the reciprocal of tangent 135 degrees. So reciprocal of this one, so we will just have x over y. So x over y, we have negative square root of 2 over 2 over y is square root of 2 over 2. And this is just equal to negative 1 also. Okay? And take note, you can have it shortcut. Since we know that tangent 135 degrees is negative 1, so reciprocal of negative 1 is just -1. So that's why cotangent 135 degrees is equal to -1. So you can actually take the reciprocal of the value of tangent right away, and you will get the value of cotangent. Okay, next we have cosecant. So cosecant 135 degrees is just the reciprocal of your sine. And sine is y, therefore cosecant is 1 over y. So we have 1 over, y is square root of 2 over 2. Okay, and this is just equal to 1 times the reciprocal, right? Because we are dividing fractions, so we will change the operation to multiplication and take the reciprocal of the denominator. So reciprocal of square root of 2 over 2, that is just 2 over square root of 2. So we have 2 over square root of 2. Since 1 times 2 over square root of 2 is 2 over square root of 2. And that is indeed the reciprocal of square root of 2 over 2, which is your sine. Okay, so you can actually take right away the reciprocal of sine. And since we have a radical expression in our denominator, we need to rationalize this one. So rationalizing, we will just multiply the numerator and denominator by square root of 2, right? So the final answer will be 2 times square root of 2 over square root of 2 times square root of 2 is just 2. So 2 here will be canceled out. Therefore, the final answer is square root of 2. Okay? So that is your cosecant 135 degrees. Now, let's proceed to secant 135 degrees. That is the reciprocal of your cosine. So that is 1 over x. So we have 1 over x is negative square root of 2 over 2. So we will now have 1 times the reciprocal. So we have negative 2 over square root of 2. So this is now equal to negative 2 over square root 2, which is indeed the reciprocal of cosine, which is negative square root of 2 over 2, right? And I want this one to be rationalized. So we have to multiply the numerator and denominator by square root of 2. So this will now be equal to negative 2 square root of 2 over square root of 2 times square root of 2, that is equal to 2. So this will be canceled out. So we have negative square root of 2. So the final answer is negative square root of 2. So we are done finding the values of the six circular functions, okay, of the angle 135 degrees using the knowledge about 45, 45, 90 triangle. So just take note of the measurements here of a 45, 45, 90 triangle given a right triangle in a unit circle. Okay, now let's proceed to negative 60 degrees. So suppose this is our unit circle. Okay, so negative 60 degrees, since the angle is negative, our rotation now is clockwise. Okay, so our initial side will still be on the positive x-axis, and the angle will, the terminal side of the angle will be located here. Okay, so this is now negative 60 degrees. So we need to know the coordinates of this point here. So the same process, okay, the same thing that we did in our angle, 135 degrees angle. So we will just project the point, okay, to our x-axis. So we have this right triangle now. Okay, so this right triangle, okay, is again a special type of right triangle. And what is that special type of right triangle? Now, taking this right triangle, since the angle here sa taas is negative 60 degrees, and since we are now taking the angles of the interior, or the interior angles of this right triangle, so the angle now will become positive. Okay, so since we are dealing with right triangles already. Okay, so from negative 60, this will now be become 60 degrees. So we have 90 degrees. So what's left for this to have a sum na 180 degrees? So the angle here sa baba should be 30 degrees. And this is now a special type of right triangle, a 30, 60, 90 right triangle. Okay? And again, this hypotenuse here is just equal to the radius, which is equal to 1. Okay, so the hypotenuse is equal to 1. Now, recall your knowledge about 30, 60, 90 triangle. So, in a 30, 60, 90 triangle, the shorter leg is half of the hypotenuse. So given the length of the hypotenuse, you can get the length of the shorter leg by getting the half of the length of your hypotenuse. So therefore, since our hypotenuse here is equal to 1, so half of 1 is 1 half. Therefore, the length of the shorter leg here is 1 half. So we have 1 half here. Next, for the longer leg, that is just square root of 3 times the shorter leg. So we will just multiply the length of the shorter leg by square root of 3. So 1 half times square root of 3, that is equal to square root of 3 over 2. So it follows that since this one now is 1 half, so the length of the shorter leg here is 1 half. So from the origin going to this side here, is equal to 1 half. And sa baba naman, yung vertical side is square root of 3 over 2. Okay, so from that, we can now um, give the coordinates of this point here. So point or P of negative 60 degrees is equal to 1 half and negative square root of 3 over 2. Since the point is located at quadrant 4. So our x is positive, our y is negative. So x is 1 half, while y is negative square root of 3 over 2. Okay, so we can now give the values of the six circular functions. So starting with sine negative 60 degrees. So that will now be equal to the value of y, which is negative square root of 3 over 2. Okay, next, cosine negative 60 degrees. That is just the value of the x coordinate, and that is 1 half. Okay. Next, we have tangent. Tangent negative 60 degrees. That is just y over x. So we have negative square root of 3 over 2 over 1 half. So we have here, take the numerator, negative square root of 3 over 2, change the operation to multiplication, and take the, what do you call this one? Reciprocal of the denominator. So reciprocal of 1 half is 2 over 1. Okay, so 2 here will be canceled out. So the final answer will be square root of negative square root of 3. Okay. Next, we have um, cotangent. Cotangent negative 60 degrees. That is just the reciprocal of your tangent. So we have x over y. That is 1 half over y is negative square root of 3 over 2. Okay, so from that, we will now have 1 half times the reciprocal of negative square root of 3 over 2 is negative 2 over square root of 3. So 2 will be canceled out, so we have negative 1 over square root of 3, which is indeed the reciprocal of negative square root of 3, which is your tangent. Okay, so there. Then we will rationalize this one. So multiply this by square root of 3 over square root of 3. So the final answer will be negative square root of 3 over 3. Okay? Next, we have cosecant, negative 60 degrees. So cosecant, negative 60 degrees. That is the reciprocal of sine or your y. So we have 1 over y is negative square root of 3 over 2. And this is just equal to 1 times the reciprocal of square root of 3 over 2. That is negative 2 over square root of 3. So we have negative 2 over square root of 3, which is indeed the reciprocal of square root of 3, negative square root of 3 over 2, right? Then we will rationalize this one, multiply this by square root of 3 over square root of 3. So our final answer will be negative 2 times square root of 3 over square root of 3 times square root of 3. That is just equal to 3. So we have negative 2 square root of 3 over 3. Okay, and for the last one, secant negative 60 degrees, this is just equal to the reciprocal of your x, or your cosine. So we have 1 over x is 1 half. So we will now have 1 times reciprocal of 1 half is 2 over 1. Or this is just equal to 2, which is indeed the reciprocal of 1 half. Okay, so we have now answered or solve the values of the six circular functions of angle 100 negative 60 degrees. Okay, so now what if the angle is not an angle in a unit circle? So meaning the circle will no longer be a unit circle. So that is a circle with radius r, okay, where r is not equal to 1. So what will be the form of our six circular functions? So we have now this one. So in general, if angle theta is an angle in standard position, and q of theta is equal to x, the point xy on the terminal side of angle theta, and the radius r is equal to the square root of x squared plus y squared, which is greater than 0, then we have the following definitions of the six circular functions. Okay, so we have this one. Okay, so sine theta now will now be equal to y over r. Okay, then cosine theta is x over r, then tangent will still be y over x. Cosecant will be r over y. So secant will be r over x, and cotangent will be x over y. Okay, so saan galing to? Now, look at the illustration dito. Okay, take note, this circle here is not a unit circle. So the radius now is r. Okay? So from that, since the radius is r, so if we have this right triangle here, this one, okay? So our y coordinate is still y. So therefore, the opposite side is has the measure y. And the x coordinate is x. So therefore, the adjacent side here is x. Okay, and we have the hypotenuse equal to the radius r. So from that, sine theta now will be equal to opposite over hypotenuse. So that will be the side opposite will still be y over the hypotenuse, which is r. So from sine theta equal to y sa unit circle, naging sine theta equal to y over r na siya. Okay, so yung 1 naging r lang. Okay, so yan lang yung difference nilang dalawa. Okay, while cosine theta is adjacent, which is x, over hypotenuse, which is r. As well as for your tangent, so that is opposite over adjacent, so opposite is y, while adjacent side is x. And just take the reciprocal for the rest of the circular functions. Okay, so actually, from this definition, yung definition for unit circle is a special case. That is when your r is equal to 1. Okay, so kung r is equal to 1, mawawala lang itong r dito. Right? So this will now be equal to sine theta equal to y over 1, or just y. Okay, so this is now the general form of our circular functions. Okay, now let's try these problems here. So we have four problems, so we will try to solve this one. So let's start with number 1. Okay, so we have to find for the values of the six circular functions of angle 150 degrees first. So angle 150 degrees, so is located at, that is more than 90 and less than 180. So it is at quadrant 2, right? Suppose this is our unit circle. Okay, this one. Okay, by the way, when the problem, hindi na-mention yung circle, if unit circle ba siya or hindi, just assume that the circle is a unit circle. Okay? Now, 150 degrees is somewhere here. This one. Okay? So, from the initial side going to terminal, that is equal to 150 degrees. Okay? Now, the same thing that what we did with our previous example, we need to know the coordinates of this point here. Okay? Now, we will project this point here to our x-axis. So we will now have this right triangle here. Now, since this is 150 degrees, it follows that this one here sa baba is 30 degrees. So therefore, this right triangle here is a special type of right triangle, and it is a 30, 60, 90 triangle. Now, suppose I will just draw this right triangle here para mas makita natin. So this is 30, this is 90, so this will be 60 degrees. Okay? And since this is a unit circle, the hypotenuse will now be equal to 1, right? So, since this is a 30, 60, 90 triangle, the shorter leg is half of the hypotenuse, which is 1 half, and the longer leg is square root of 3 times the shorter leg. So, we have square root of 3 over 2. Okay? So, it follows that the value here in our x-axis will be this one, square root of 3 over 2. And since the angle is located at quadrant 2, so this will now be equal to negative square root of 3 over 2, right? And our y here will be the value of our side here. So this is 1 half, positive. Okay, so our point here will be negative square root of 3 over 2 and 1 half. Okay, so let's start with sine 150 degrees. So sine 150 degrees now will be sine 150 degrees will be the value of y, and that is 1 half. Okay? Then cosine 150 degrees will be the value of x, which is negative square root of 3 over 2. Then tangent will of 150 degrees will be y over x, so that is 1 half over negative square root of 3 over 2. And this will now be equal to, so I will solve this directly. So this is negative 1 over square root of 3. Then we will rationalize this one. So multiply it by square root of 3 over square root of 3. So the final answer will be negative square root of 3 over 3. Okay? Next, cotangent. So cotangent 150 degrees. So that is the reciprocal of your tangent. Okay, so that will be negative square root of 3 over 2, which is your x, over y, which is 1 half. And this will now be equal to negative square root of 3. Next, cosecant 150 degrees, that is 1 over y. So y is 1 half. So 1 over 1 half is equal to 2. And lastly, second 150 degrees, that is just 1 over x. So x is negative square root of 3 over 2. And this will now be equal to negative 2 over square root of 3. Rationalizing, multiply this by square root of 3 over square root of 3. So our final answer will be negative 2 square root of 3 over 3. So these are the values of the six circular functions of angle 150 degrees. Okay? Next, let's have letter B, 3 pi over 2. So first, let's locate 3 pi over 2 in our unit circle. So suppose this is our unit circle. Okay, so this is now our xy plane. Okay, so 3 pi over 2 is somewhere here. This one. Okay, so this is angle 3 pi over 2. Okay, so therefore, this point here, we already know that this is a unit circle. So therefore, this point here has the coordinates 0, negative 1, right? So our x is 0, while our y is negative 1, since it is at negative x-axis. Okay, so we can now give the values of the six circular functions. So first, let's have sine 3 pi over 2. So sine 3 pi over 2 is the value of y, which is negative 1. Cosine 3 pi over 2 is the value of x, which is 0. Tangent 3 pi over 2 is y over x. So we have negative 1 over 0, which is undefined. Okay? Next, we have cotangent 3 pi over 2. This is x over y, 0 over negative 1. So that is now equal to 0. Next is cosecant 3 pi over 2. That is 1 over y. So 1 over negative 1. This is equal to negative 1. And second, um, 3 pi over 2 is 1 over x. So we have 1 over 0, which is undefined. So these are the values of the six circular functions of angle 3 pi over 2. Okay? And for the last one, 4 pi over 3. So let's locate this angle in our unit circle. So suppose this is our unit circle. Okay, so let's locate 4 pi over 3. So 4 pi over 3 is somewhere here at quadrant 3. So this is now your 4 pi over 3. Okay, so just locate 4 pi over 3. So this is 4 pi over 3. So we need to know the coordinates of this point here. Now, if I'm going to project this one here in our x-axis, so I will now have a right triangle here. And take note, the measure of this one here is just 60 degrees. So this is 60 degrees. So from that, we now have a 30, 60, 90 triangle. So 60, 90, so we have 30. Okay? And since the hypotenuse is 1, since this is a unit circle, so therefore this shorter leg here is 1/2, and the longer leg here is the square root of 3 over 2. So it follows that the value here in our x-axis will now be equal to negative 1/2. And the value here in our y-axis will be negative square root of 3 over 2. So the coordinates of this point here will be negative 1/2 and negative square root of 3 over 2. So this is your x, while this is your y here. Okay, so that one. So we can now give the values of the six circular functions. So let's start with sine 4 pi over 3. So sine 4 pi over 3 is just the value of y. So we have negative square root of 3 over 2. Then cosine 4 pi over 3 is just the value of x, that is negative 1/2. So as you can observe, the values of these um, angles, okay? So nakapalibot lang siya sa 1/2, square root of 3 over 2, 1, square root of 2 over 2, okay? And the reciprocals, right? And as well as 1, 0. Kasi yung mga angles na kinonsider natin ay mga special angles. So the values are revolving lang sa mga values na to. Okay? Next, tangent 4 pi over 3. So that is y over x. So we have negative square root of 3 over 2 over negative 1/2. And this is just equal to positive square root of 3. Okay. Next, cotangent 4 pi over 3. That is just x over y. So we have negative 1/2 over negative square root of 3 over 2. And this is just equal to 1 over square root of 3. Then we rationalize. So this will now be equal to square root of 3 over 3. Okay? Then cosecant 4 pi over 3, that is just 1 over y. So 1 over negative square root of 3 over 2. This is just equal to negative 2 over square root of 3. Then we will take we will rationalize this one. So this will now be equal to negative 2 square root of 3 over 3. And lastly, we have secant 4 pi over 3. So this is just 1 over x, which is 1/2. So this is equal to 2. So we have answered problem number 1. Okay? So there. Now let's proceed to problem number 2. So we have here, suppose theta is a real number such that sine theta is equal to negative 3/4 and cosine theta is greater than 0. We need to find for cosine theta. Okay. So here we can actually have two approaches. So the first approach is when we assume that the circle is a unit circle, while the second approach is when the circle is not a unit circle. So first one, suppose the circle is a unit circle. So we have here a unit circle. So the given values are, first we have sine theta, which is equal to negative 3/4. Now take note, in a unit circle, sine theta is just the value of y. So it follows that y is equal to negative 3/4, right? Next, we need to find for the value of cosine theta. And take note, cosine theta is just equal to x, and that should be greater than 0. So ito yung hinahanap dito, the value of x. Now recall, okay, any point on the unit circle must satisfy to the equation x squared plus y squared equal to 1, right? So therefore, given y, we can actually solve for x using this formula here, right? So from that, we can just do direct substitution to solve the problem. So we have our x is unknown, so x squared plus y is negative 3/4. So we have negative 3/4, then quantity square. And we have equal to 1. Then solving, we have x squared plus negative 3/4 squared is just 9 over 16, which is equal to 1. So in solving for x, we will just add negative 9 over 16 both sides. So we have x squared na lang sa left side equal to 1 minus 9 over 16, right? And this will now be equal to x squared equal to 16 minus 9 over 16, that is 7 over 16. Now, since we are just going to solve for x, so we need to extract the square root of both sides. So we have to take the square root of both sides here. It will follow that x will now be equal to plus or minus square root of 7 over square root of 16 is 4. So from here, we have two values of x, positive and negative square root of 7 over 4. But take note, from the given problem, cosine theta should be greater than 0. So our x here should be greater than 0. Therefore, our x should be positive. Thus, cosine theta now, which is your x, will now be equal to square root of 7 over 4, the positive one. Okay? So that answers our problem. So this is using the unit circle approach. Now, how about if the circle is not a unit circle? Okay? So this is for circle, okay, with radius r. Okay? Now, what are given? So, sulat ko ulit yung given. Si sine theta is equal to negative 3/4. Now, in our unit circle, in our circle with radius r, sine theta is just equal to, so note that sine theta is equal to y over r. Therefore, it follows that y over r is equal to negative 3/4. Okay? So it follows now that we can have this y equal to negative 3 and r equal to positive 4. So our radius should always be positive. That's why r is 4 and y is negative 3. So we now have the values of y and r. Okay? And we need to find for the value of cosine theta, which is just x over r. And this should be greater than 0 or positive, right? Now, recall the formula sa radius ng circle with radius r. So we have this equation. R is equal to the square root of x squared plus y squared, right? So it follows that squaring both sides, r squared is equal to x squared plus y squared. Now, since we have the values of y and r, we can solve for x. So by direct substitution, r is 4, so we have 4 squared equal to x squared plus um, y is negative 3, so negative 3 square. So 4 square is 16, equal to x square plus negative 3 square is 9. Solving for x, we need to add both sides by negative 9. So we have 16 minus 9 equal to x square. And this is just equal to 7 equal to x square. Now, since we are just going to solve for x, so we need to extract the square root of both sides. So it follows that plus minus square root of 7 is equal to x. So we have two values of x here. But take note, our cosine theta should be greater than 0, so x should be positive. Thus, cosine theta will now be equal to x over r. So the x that we're going to take is positive square root of 7 over r is 4. So cosine theta will now be equal to square root of 7 over 4, which is the same with what we got sa unit circle approach. Okay, so either way, we must end up with the same answer. Okay, so that is for number 2. Now, for number 3, okay, we need to find for the values of the other circular functions of angle theta such that cosine theta is equal to 3 over 10. And theta is between 3 pi over 2 and 2 pi. Okay, so if this is our Cartesian plane, okay, so 3 pi over 2 is located here, right? And 2 pi is here. Therefore, our angle is between here. So, therefore, angle theta is in quadrant 4. Okay, so that is now our assumption. Okay, so suppose we are going to apply the unit circle approach. Okay, so we have unit circle. So what are given here is that sa cosine theta is equal to 3 over 10. Okay, so it follows that x is equal to 3 over 10 since this is a unit circle, right? And angle theta is in quadrant 4. So if the angle is in quadrant 4, our x is positive and y is negative. Okay, so we need to find for the values of the other circular functions, yung lima. Okay, and we have the equation so that we can solve for y. So the equation will be x squared plus y squared equal to 1. Now, substituting for the value of x, so to solve for y, we have 3 over 10 square plus y square. This is now equal to 1. 3 over 10 square is 9 over 100 plus y square equal to 1. Solving for y, we will now have y square equal to 1 minus 9 over 100, right? So 1 minus 9 over 100 is just equal to 91 over 100. Now, extracting the square root of both sides so that we can solve for y now will be equal to plus minus square root of 91 over square root of 100 is 10. So we have two values of y here. But since the angle is in quadrant 4, so we will just take y na negative. So here, y is equal to negative square root of 91 over 10. Okay, over 10. Okay, so from that, since we have the values of x and y, we can now give or solve for the values of the other circular functions. So let's start with sine theta. So sine theta will be the value of y, and that is negative square root of 91 over 10. Cosine theta, there's no need to solve for that because that is given. Next, tangent theta. Tangent theta is y over x, so y is negative 91 over 10 over x is 3 over 10. So from here, we will now have negative 91, square root of 91 over 3. So that is your tangent theta. Okay? Next, for cotangent theta, we will just take the reciprocal of tangent. So kunin nyo na lang agad yung reciprocal ng negative 91, square root of 91 over 3. And that is negative 3 over square root of 91. Then we will rationalize this one. So multiply both sides by square root of 91. So this will now be equal to negative 3 square root of 91 over 91. Okay? Next, for cosecant, so dito na lang, cosecant theta will be the reciprocal of your sine. So reciprocal of negative square root of 91 over 10 is negative 10 over square root of 91. Then we will rationalize this one. So the final answer will be negative 10 square root of 91 over 91. Okay? And lastly, for secant theta, reciprocal of cosine. So reciprocal of 3 over 10 is just 10 over 3. So those are the values of the 6 circular functions using the unit circle approach. Okay, so that's it for this one. Now, how about if the circle has the radius r? Okay, so this is for the circle with radius r. Okay, so given is cosine theta, which is equal to 3 over 10. So it follows that cosine theta, which is equal to x over r is equal to 3 over 10, right? So it follows that x is equal to 3 and r is equal to 10. Okay? So from that, we can now solve for the value of y using the equation x squared plus y squared equal to r squared. Okay, so galing ito sa r equal to square root of x squared plus y squared, right? So we have this one. Now substituting the values of x and r, so we have 3 square plus y square is equal to 10 square. So we will now have 9 plus y square is equal to 100. Now, solving for y, so we have y squared equal to 100 minus 9. So, y squared is equal to 91. Then, taking the square root of both sides, y is equal to plus minus square root of 91. Now, since the angle here is located at quadrant 4, so we will take y equal to negative square root of 91. Okay, so from that, we can now look for the values of the other 6 circular functions, other 5 circular functions rather. So first, we have sine theta that is equal to y over r. So y is negative square root of 91 over r is 10. Okay, which is the same with our answer in our previous solution. Okay, then tangent theta will be um, y over x, and that is x is 3 over, oh no, y first, y. So y is negative square root of 91 over x is 3. Okay, so there. Next, cotangent theta will be the reciprocal of this one, tangent. So that will be negative 3 over square root of 91. Then we will rationalize. The answer will be negative 3 square root of 91 over 91, which is the same with our first solution. Then cosecant theta, reciprocal of this one. So we have negative 10 over square root of 91. Then we will rationalize. So the final answer will be negative 10 square root of 91 over 91. And the last one, secant theta, reciprocal of your cosine, and that is 10 over 3. So that answers our problem number 3. Okay? So for the last one, so find the values of the other circular function. So the same with number 3. If cotangent theta is negative 5 over 12 and theta is at quadrant 2. So first, we will apply the unit circle approach. So given values here is cotangent. So cotangent theta is equal to negative 5 over 12. And theta is at quadrant 2. Okay, so at quadrant 2. Now, cotangent theta in a unit circle corresponds to x over y, right? And that will now be equal to negative 5 over 12. Now, this is the common mistake of students whenever they are using the unit circle approach. They will correspond x as negative 5 and y as positive 12. So take note, if that's the case, if we have the formula x squared plus y squared equal to 1, so negative 5 squared plus 12 squared will no longer be equal to 1. So if that's the case, we can just have this one. So we will just solve for x in terms of y. Whenever we are solving for um, the values of the other circular functions, okay, using the unit circle approach. So here, x is just equal to negative 5y over 12, right? So we now have this relationship. So from here, we can now solve for the value of y using the equation x squared plus y squared equal to 1. So from that, x is just negative 5y over 12, then quantity square, plus y square equal to 1. So we will now have negative 5y over 12 square is 25, y square over 12, no, 144. So this is 144 there, plus y square equal to 1. So we will now have 25y square over 144 plus y square is just equal to 169 um, y square over 144 equal to 1, right? So for this 169 over 144 to be eliminated, we will multiply both sides by 144 over 169. So multiply this also by 144 over 169. So this will be canceled out and this one also. So y squared now will now be equal to 144 over 169. Then taking the square root of both sides, so y will now be equal to plus minus 144. Square root of 144 is 12. So square root, that will be plus minus 12 over 13. Okay? And since our angle is at quadrant 2, so um, y should be positive, right? Quadrant 2. So 12 over 13. While our x, we will just substitute this value of y here to our x. So x will now be equal to negative 5 times 12 over 13 over 12, right? And this will now be equal to negative 5 over 13. So that is now the value of our x. So from that, we can now solve for the values of the other circular functions. So first, we have sine theta. Sine is the value of y, which is 12 over 13. Then cosine theta is the value of x, which is negative 5 over 13. Now, tangent theta is the reciprocal of cotangent. So that will be the reciprocal of negative 5 over 12. Since our cotangent is negative 5 over 12, so that will be negative 12 over 5. Now, cotangent is already given, so we will proceed to cosecant theta. Cosecant is the reciprocal of sine, so that is 13 over 12. And secant theta is the reciprocal of cosine, so that is negative 13 over 5. So those are the values of the other circular functions of angle theta, given that cotangent theta is negative 5 over 12. Now let's try the other approach. Okay, so this is for the circle with radius r. Okay, so given cotangent theta is negative 5 over 12. So cotangent is just x over y. So that is negative 5 over 12. So it follows that x is equal to, since the angle is at quadrant 2, so x should be negative. So we have negative 5. And y is positive 12. Okay, so from that, we can now solve using the equation x squared plus y squared equal to r squared, right? So x is negative 5, so square plus y is 12 square equal to r square. So this will now be equal to 25 plus 144 equal to r squared. So 25 plus 144 is 169 equal to r squared, taking the square root. So r is always positive, so we will just write the positive one. So square root of 169 is 13. So r is 13. Thus, sine theta will now be equal to y over r, and that is 12 over r is 13. So the same with what we got from our previous solution. Next, cosine theta is x over r. So that is negative 5 over 13. Next, tangent theta is the value of the reciprocal of cotangent. So you have negative 12 over 5. Then cosecant theta, reciprocal of sine. So you have 13 over 12. And secant theta is the reciprocal of cosine. So you have negative 13 over 5. So we have answered problem number 2. So either of the two approaches, you will end up with the same answer. Okay? So I think that's it for this video for today. So the second part will be on reference angles. Okay, and we will tackle there how to use reference angles in finding the exact values of the six circular functions. So that's it for this video. Thank you for watching.